Alright guys, here's a question from Chapter 8, Section 2. It's involving proportions. So Section 1 was involving means. Section 2 is involving proportions. So first thing it asks, it's a vocab type question. Why can we use a normal distribution to do this? And so what we have is our sample is less than 5% of our population. That's what this part here stands for. And that's just saying that if I had more than 5%, then maybe when I was randomly picking people, that I might pick the same person more than once. We'd have a higher chance if we were doing a larger percentage of our population. So our sample is less than 5% of our population. 300 is less than 300 over 20,000 doesn't represent 5% of our population. It's less than that. And then n times p times 1 minus p has to be greater than or equal to 10. So that's another stipulation that we have to say it's normal. So when we are determining the mean of the sampling distribution, that's just going to be our sample size, or it's going to be our population proportion, sorry, so the 0.4. So we would expect our p hat to be around 0.4. So again, we don't have to do any calculations for this one, it's just what our population proportion is. To figure out the standard deviation, that's when we have to use the formula. The formula you'll find on page 382 of your book, and it's this one right here. So the square root of p times 1 minus p over n. So let's calculate that value. I'm using my TI again, your basic calculator will work. So if I do p 0.4 times 1 minus 0.4, which is 0.6, divided by n, our sample size is 300. And if we compute that, we get that value there, and they said 3 decimal places, so 0.028 would be our value there. So that's just how we get our mean of our sample distribution of p hat, and then the standard deviation of the sampling distribution of p hat. But what we're going to do is we're going to end up using these values when we're finding out what's the probability that it's high or probability that it's low. Let's see if I can find one that's asking us to do that. So we're going to assume that it's approximately normal, and we could calculate this one real quick. So the standard deviation would be the square root of 0.31 times 1 minus 0.31, so 0.69, divided by our sample, which is 1,000. So here's our standard deviation, the 0.0146, so we're looking at this one here. Alright, and again, the mean of our p hat is our hypothesized proportion, the 0.31. Now we're trying to find that the probability that x is greater than or equal to 340. So now we're going to use our stat crunch to help us figure this out. So if we go to our normal calculator, just like we were doing in Chapter 7 and in 8.1, our mean was that value that we had for our p hat, so 0.31, and our standard deviation was the 0.0146. So that's the information that we're going to use, 0.31 and 0.0146. 0.31 and 0.0146. Now they gave us a big number on this question. They said greater than or equal to 340. You know, so what does 340 mean to us? We're dealing with proportions. So it said greater than or equal to 340, but 340 is really 340 over 1,000 because it's a proportion. So 340 out of the 1,000 would be a 0.340, or just 0.34. And now we can find that probability. So if we had 34%, 0.34, that would only be a 0.0199. I think they're asking to 4 decimal places. So 0.0199 should be our answer for this one. Right? So we're plugging into StatCrunch the mean and then our standard deviation for a proportion, and then they gave us x, but we want to change that to a proportion as well, so the 0.34. And then the last question, so less than 290, right? And so it's doing the exact same thing. We're doing a less than, and 290 out of 1,000 is 0.290. And that's where we get the 0.0854. So let's verify that. 0.0854. So that should give you the ideas of the Section 2, Chapter 8.